Right, let's quickly look at this question about limiting reactants. So we're going to look at this question about the reaction of sodium with iron oxide. So if you have 100 grams of sodium and you have 100 grams of iron oxide, and you want to find out which one of them is the limiting reactant, you can use any of these products to do that, but I'm going to use iron because it's the easiest one to use. So we know that one iron is 56 grams per mole. So on the top here, I've already written in the molar masses because I'm using sodium. One sodium is 23 grams. Remember, molar mass, you ignore the coefficients in front. So that's one sodium for 23 grams. Then there's two irons. That's 2 times 56 plus 3 times 16 gives me the 160. And then iron on its own is 56. So we ignore the coefficients in front when it is molar mass. If we want mass, then we will add it in. Okay, so you have to take each of these products and find out how much iron is going to give you. So I'll start with the first one. That is, if I have 100 grams of sodium, and I want to know how much iron is that going to produce. So I want to get the grams of iron. So this is what I know, and this is what I want to know. So I'm going mass to mass. If I'm going to mass calculation, I need 3 conversion factors in order for me to get my answer. One on the top, one at the bottom here. The one in the middle is plain straightforward ratio. So I go to my sodium and I see I have 6 sodiums, which means I put a 6 at the bottom. And then I want to know how much iron. I go to the iron, I see there's a 2 in front, so I'll put a 2 on the top. The molar mass for sodium goes into the first bracket. See, sodium is right next to it. And molar mass of sodium is 23. And the molar mass of iron goes into the last bracket. It's closest to the iron, so that gives me 56. I have to put this into my calculator and calculate the answer. So let me do that quickly. Right, so I put all of that into my calculator as I've written it there, get my answer, and I see that the mass produced is 81.15. And because of the 9, it will become 6, so it's 81.16. 81.16 grams of iron. So that's for the first one. I now go and do the same for the iron oxide. So I've got 100 grams of iron oxide, and I want to know the grams of iron. So I'm going mass to mass. Mass to mass, again, I need 3 conversion factors. One on the top there and one at the bottom here. In the middle, I'm now going to put my ratio, and now I'm working with iron oxide. So I go to iron oxide and I see it is 1. And iron, as we've already seen, is a 2 on the top. I will put my molar mass for iron oxide over here, which I've worked out there to be 160. And on this side, I will put the molar mass of iron, which is 56. Right, so let's work that answer out quickly. And my answer is 70 grams of iron. Okay, so the 70 grams is the least because 70 grams is the lowest number. Lowest, least, then it means that because this is my lowest number, iron oxide is my limiting reactant. Because this one gives me the least iron, both of them, I'd see how much iron I will get. But this one gives me the least iron, which means all my iron oxide will be used up. I will still have iron left. This one gives me more iron, so that is my excess reactant. So sodium is the excess reactant. Because I get more iron there than iron here, this is excess. Because I get less iron here, this is the limiting reactant. Okay, so this is when you're doing mass to mass to calculate the limiting reactant. If I want to know how much product I'm going to produce or how much iron I'm going to produce, I don't need to calculate it again. I'm going to produce 70 grams of iron. Remember also that this 70 grams of iron is also known as my theoretical yield. Theoretical yield is the yield that I get due to calculation. Okay, so the next one, I will change the question and show you how do you calculate it if you are given the number of moles and you have to do a mole to mass calculation.